So what's Q hat going to be? Yeah, 0.296, because no matter what kind of clothing they're wearing, what do P and Q do when they're added together? They make 1. Because P is the probability of success. Q is the probability of failure. So that covers everything. I like it. What else do I need? How do I get the z-score for this? Yeah, how confident do we want to be? 96%. That's not on the little baby chart. Aw. So how do I do it? I have to do it the old-fashioned way. There's 96% inside. There's 4% outside, so 2% on one side. And the closest you can get to 0.02?
Is it 2.0?
0.05. I like it. So 2.05. So Z is 2.05. I like it. Yes?
Okay, so let's say in the test we just remember, like, 0.96, if we remember the confidence, like the z-score for 96, for like 99, for like 97, and we just remember at the top of the head, we have short. Like, I don't know, you know what I mean? Like, will you count points? You know, like, you're in the test, you're like really getting through it, and you're like, you forget to show this. Will you get, like, should I be worried about that?
Yes. This is something you should be able to do, period. So yeah, I'm going to want to see it. And you know I'm going to give you at least one problem that's got some confidence level that you haven't done. You know I am. So, and I know that several of you want to live inside your calculators. I know this. And I don't give a shit. I don't know if you had a previous teacher that lets you just push buttons and get all the answers. I know there's a lot of teachers right now on this campus that do the same thing. I'm sorry. I'm like you to understand concepts. I don't know if that's a crazy thing or not. So yes, I want to see where it came from, because I'm always worried it came from some little black box and not your understanding of how to get it. All right. So let's see what else. So I got everything I need, right? The one thing I haven't really written out is N. But what's in it? 652. Be careful. It's always the biggest number if you got to go that way. All right. So total things I was looking at. So now I've got everything I need for the formula. So I got P hat is 0.704. So it'll be P hat, give or take, all this business. 0.704, give or take, 2.05. And by the way, that's why I always just write the number down. Where's the negative positive? Well, it's built in. It's built into the formula, right? The plus and minus. All I care about here is the number. Don't put a negative in there and freak yourself out and go, what's plus or minus negative? It's the same thing. Square root, 0.704. Here's where you got to be careful. If you got the newer calculator, the square root sign just gets bigger, so you know that it's not coming out. But if you close a parenthesis on the older ones, that means you've come out of the square root. So don't close a parenthesis until the very end. So it'll be times 0.296 divided by, what was it, 652, close parenthesis. Again, if you got the newer one, you don't need parentheses at all. I like it. Just square root gets bigger. That's awesome. Okay, I like it. If you don't have any calculator at all, then it just depends on what you end up with when you borrow one. Is everybody, how we doing? Is everybody cool with what's happening up here? I'll take that as a yes, okay. And then I can figure out the error. What's the error going to be here? Do you? 0.0366. So what you guys got? Yes, okay. And now I just subtract that, add that. That'll be 0.6674. So that's a real quick thing you can write for yourself. That's the interval. That's good old interval notation. No shit from algebra, right? So we have constructed an interval, and we hope our interval catches the real percentage of the whole population. That's the whole purpose of this. So the real percentage is sitting somewhere. We calculate a p hat, and we hope to God our interval catches it. What's the chances that our interval caught it?
96.
96% chance. I like it. So we feel pretty decent about the results here. 4% chance of being wrong. Again, like my standard joke is, it's better than normal for me. So, how do I write the conclusion? Did you guys write the conclusion yet? If you haven't, take a second, try to write it. Because you're going to have to write this on your own eventually. So we are 96% confident that the interval,
0.6674.
better than that?
66.7%.
Yes, 66.7. The percentage acts as the units now, right? 66.74% to 74.06%. We hope that that contains the actual, the real population percentage. And the interval contains what I call the true, but it's the population percentage. The true percentage, what was this problem about?
Proportion of people that voted.
Oh, portion of people. Can't do P's, that's too bad. Percentage of people that voted in the last election. Blah, blah, blah. That's actually a really good turnout. I don't know if I got that. I don't remember the last time I made this sheet. Last time I updated it. That is crazy high for any part of America, unfortunately. Being governed by people that 20-something% of people picked. Isn't that crazy? Oh well. All right. It's all an experiment. We'll see how it comes out. How do you guys feel? The really nice thing about every formula, we got one more formula to talk about. It's basically going to be the same as the X bar one with a couple of little tweaks. You should be used to this idea of tweaking things based on the situation. Oh yeah, before I get too far, we do have to finish that side out, and I do want to talk about what that check NP hat, NQ hat means. The really funny thing, remember P hat was 459 over 652, right? Which is X over N. So can somebody tell me, without doing much work, I know the P hat was like 0.704 when you rounded it. What is NP hat going to be? You can do it. I have faith somebody in there can do it. P hat is X over N. Yeah. So N times P hat must be 459. It's the number of successes. That's what NP hat is like the average success. So that's the number of successes I see in my sample, 459. So what is NQ hat going to be then? Dude, how would you calculate it? It must be the other people. They must be failures. Huh? Yeah, so it'll be 193. Oh, 93. 193, Jeff, you got it.
Yeah.
Okay. I get there eventually. Now, here's the idea of this. What part of this did we not even address? That was a huge concern before. When am I allowed to use z-scores the way that we just did? Only if it's normal. Only if it's normally distributed. So there was that handout a while back. Ooh, that's everybody. Hello. Remember this handout? No? Okay, here. This was me plotting all the individual probabilities. You flip a coin 14 times, and this is plotting the probabilities of getting this many heads. Yeah, I like it. Would you say this looks normal? Yes, and you would be right if you thought so. If you thought no, then no, you're wrong. This is completely nicely normal. Now listen, what would change? Why was this one the highest one? Because out of 14 flips, what's the average number of heads I'd expect? 7. I like it. Now what if this penny had been weighted so that it came out almost always to tails? Like 90% of the time it came out to tails. You guys with me? What would the highest bar be then? Well, what's 90% of 14? 29 times 14, let's see, 9 plus 12.6, no, 12.6. Who's it?
12.6.
Oh, okay. Here we go. So the highest bar would be like around 12 or 13. Are you with me? I like it. I like it. Please be with me. So if that had been weighted, then I'd expect it to be 90% of the time heads. Then I would expect the highest bar to be up here. Does that give it enough room? What happens after this? Can it go after that? It doesn't exist after that. That's the number of flips. If you get 15 heads on 14 flips, you got to concede, right? So would it have enough room to go up and then come back down if that was too high? No. And what if it was too low? What if the probability, what if n, what am I trying to say? What if n p hat was too small, the same problem would happen. Are you guys with me? So, here's how we do this. And we take care of this by bringing in the Q hat. It would really suck to have a rule that depended on n, on the maximum, because then I'd have to have a slightly different rule for the number total, right? So what we do is we do this. NP hat, the mean, cannot be too small. It can't be too small, or else there's not enough room to go up and down. It would start high and go low. That's not normal at all. There has no chance to be symmetric and nice and normal. So I want to pull the mean out far enough so it's got room to go up and down. So it turns out that's got to be more than 5. Well, I think this book says at least 5. I can't remember. Different books say different things about 5. So does that make some sense? It's just giving it enough room. Giving it enough room. If I'm going to here with my highest bar, now it's got room to go up and come back down. And then it will be normal enough. To take care of the other side, we look at the failures. If the number of successes has to be at least 5, the number of failures also has to be at least 5. That basically takes care of the other side. So if these two things are true, if these two things are true, then your probability stuff is normally distributed enough. We would be allowed to do everything we just did. That's why I had a little part to this handout that said check NP hat and NQ hat. I like it. So let me ask you this. If I took a poll of 27 people and 23 of them said yes to something, right? See if you guys really, really get this. Do you have to calculate p hat to see what NP hat is? What's NP hat? I don't know if you don't believe me. What's p hat going to be? How would I calculate p hat? You can do it. I barely told you anything, but I've given you plenty enough for p hat. What's p hat going to be? How would you calculate it? 23 said yes out of 27. Always small divided by big. So 23 divided by 27. And what's n? 27. So you do 27 times 23 divided by 27, and remarkably enough, you get 23. Always. You're always going to get the number of successes, because that's what NP hat is the number of successes. So do you actually have to do any p hat work to get this? No, you just see it. And what's NQ hat got to be? It's got to be the other people. How many other people?
4.
4. Is this approximately normal? Is this normal enough for me to do stuff? No, it's not. Why? Because NQ hat is
Less than.
not greater than or equal to 5. It's less than 5. Shit. Nope. Not normal enough. Too bad. Can't do shit. So I will say, like, check NP hat, NQ hat, and I will say it just like that. And if you just stop here, 23 and 4, or you just stop there, and you don't tell me what the hell, you don't say it's greater than 5 or less than 5. You got to actually check it. You got to actually show me that it meets the requirement, being at least 5. I like it. Maybe. And see, that jives with the rest of this class. Every time, haven't we been stopping? Did I say it was normal? Well, the sample size is big enough. Oh, thank God, we can go forward. Every problem has been like, can we use a z-score chart? Do we know it's normal? Oh shit, do we know? Same thing's going to happen to this. I want to use a z-score chart for this kind of problem. So what's got to happen? It's got to be normal enough. And this is the check for NPQ problems, is this. I like it. For sample mean stuff, what's the check? The sample size has to be. Sample size has to be over 30. That's that check, right? For sample mean kind of stuff. Unless I just say it's normal. I love it. Okay. So, the rest of that handout should look vaguely familiar to something we did before. Remember, for means, we got this formula here. If you weren't here for that, you can watch that. Some algebra happened. Algebra has a purpose besides torturing people and making it hard to get degrees. There's a reason we learn it. It's useful. For p hats, I do the same kind of thing. This part, of course, is the error. So I got the error is z times this business. How do I solve that for n? I love you guys. Like some of you guys give up before you even try something. Where is n? It's doubly sucks where it is. Where is it? It's underneath the radical and it's on the bottom. So let's take care of the radical first. How do I kill that radical? Square both sides. I like it. So square. So I got e squared equals z squared times p hat q hat over n. Who remembers the little thing I said when we did this? What can I switch? I don't want that over there. I want n over there. I can switch them. Multiply by n, divide by e squared. So n equals z squared p hat q hat over e squared. You see how that looks very similar to this? In place of sigma squared, there's p hat q hat. I love you guys. Okay, and again, it's got this on that sheet for you. So try to do that. Let me just ask you this one. 2a is a little evil. What does it look like I need to be able to do this problem? I need the confidence level. I need to know how close I want to be, what my error is supposed to be. And I need to know p hat, q hat. Where do I get p hat and q hat from? Where do I get it from? A really strange story. From where? True, but where's it come from? Why has it got a hat on it? Just like, why has X got a bar on it? Because it came from a sample. So I get p hat and q hat from a sample. What if I haven't taken a sample yet? I want to know how big of a sample do I have to take to be able to, oh shit, I haven't taken a sample yet. So when you don't know what the percentage is, what's your best guess? 50%. And mathematically, putting 0.5 and 0.5 makes n the biggest it could be. So if there's something you don't know, shouldn't you have to suffer for that somehow a little bit? Or shouldn't you have to cover yourself for that? So if we don't know p hat and q hat, we have to put a 0.5 and a 0.5 because that makes n the biggest so that we cover our ass for whatever situation is. So try to do 2a and 2b on that handout. Please notice it's its own problem. It has nothing to do with number one. Gonna try to sneak number one stuff in there.